Okay, so let's do another example of arc length. Okay, so I've got these equations here. And so I'm going, again, I want to find the arc length of the curve that's represented by these parametric equations over the interval from 1 to 3 for t. So again, I'm going to use the appropriate integral, which is going to be S is the integral from a to b of the square root of what? It's going to be x prime of t quantity squared plus y prime of t quantity squared dt. Okay, that's all I'm going to use. So now all I'm going to do is plug in the values, okay, that I need and the functions I need. So this is going to go from 1 to 3. And the derivative of x of t is what? 6t, right? So it's going to be the square root of 6t squared. So quantity squared. Plus the derivative of y, which is what? 6t squared. Quantity squared dt, okay? So again, all I did was plug in the values, so 1 to t, the derivative of x of t is 6t, the derivative of y of t is 6t squared, okay? And I plugged it in here. Now let's simplify. So what do we get? We get the integral from 1 to 3, and what do we get? We get the square root of what? We get 36 t squared plus 36 t to the fourth dt, which is then going to equal the integral from 1 to 3. Now I'm going to factor out the 36 and a t squared. So I'm going to write this as the square root of 36 t squared times 1 plus t squared dt. Actually, I don't want to do that. I want to keep the t in there. It'll make it easier. Actually, you know what? I'm going to pull it out. T squared, and we get 1 plus t squared. Yeah, let's just go with it. See what happens. Okay. So what do we get now? What do we get now? Okay, so now let's simplify this even further. So we can get 36t, right? So this is going to be integral from 1 to 3. And this will become what? A 6t, right? So this will become 6t times the square root of 1 plus t squared dt. Aha! Okay, so now we have to do u substitution. Okay, so now let's do u substitution. U equals 1 plus t squared. Okay, so then du equals 2t dt. Right? So that means there's a couple ways I could do this. I could just divide both sides by 2, right? And just make this 1/2 du is equal to t dt and do my substitution, right? I could pull the 6 out, right? So let's do that. So if I pull the 6 out, I get the square root or the integral of 1 to 3, and so t dt becomes 1/2 du, right? So I have a 1/2 in here, and then I get the square root of u du. Okay, so I could do it that way. And then if I pull the 1/2 out, I get 3. Right? So I get 6 divided by 2, right? Which is just going to give me 3. Okay, or I could leave du is equal to 2 times t, right? And I can say, hey, there's 3 of those in here. So so I can write this as 3 times 2t dt, and I get the same result. Okay, so either way is fine. Okay, so now let's integrate this thing. Oh, before I integrate, I got to change my limits of integration, right? Because so when t is 1, u is 2, right? And when t is 3, u is 10. So now my limits of integration are going to go from 2 to 10. And now we can finish this thing. So now we integrate the square root of u, right? So that's u to the 1/2. So if we integrate that, that's going to go to the 3/2, right? So this is going to go to u to the 3/2. Oh, let me write this a different way. Hold on. Okay, so 3, and then this u to the 1/2 is going to go to 2/3 u to the 3/2, and then we're going to evaluate that from 0 to 10. Okay. And so now notice that the 3's cancel here. And so this is just going to become 2 times this evaluated at 10 minus this evaluated at 0. Well, at 0, it's just 0, so I can just ignore that. So this becomes 10 to the 3/2. Okay? And that's pretty much it. So again, we could cube this. Right? So this can be written as 2 times the square root of 10 cubed. Right? Well, this is just going to be what? 2 times the square root of 10 squared times 10, right? And so this is going to become 20 times the square root of 10. And that is our answer. Okay, so the arc length for this parametric curve from 1 to 3 for t is 20 times the square root of 10 units. And that's it. Have a great day, and I'll talk to you next time.